All right, so another thing explained by electrochemistry is corrosion. And so corrosion is defined as the degradation of metals by electrochemical processes. And so this is something that costs, countries and businesses millions and billions of dollars. So there's a lot of effort trying to prevent corrosion, right? We use a lot of metals in boats and whatnot, buildings, yada, yada, yada. So there's a lot of money spent trying to prevent corrosion. One of the most popular examples is kind of the Statue of Liberty, right? So, but it's made out of copper. But if you think about a penny's not green. And so some of this is due to corrosion. It's not all due to corrosion. So you can see your book for details of the OpenStax book, and it's on page 923. But it's a pretty cool example. Probably the most popular example of corrosion is rust, right? If you let iron just sit out there, it will rust and then kind of become useless because iron oxide does not have as good of properties as regular iron. So here's what's going on in corrosion of iron. You can see this iron solid is being transformed into this iron 2+, which can then be oxidized into iron oxide. And so one of the main components here is acid. You see there's an H+ there. And so because of this, this is why kind of acid rain is causing more corrosion and all the other environmental effects that we've talked about. So let's take a look at what they mean by cathode and anode. So you have this kind of piece of metal here. You have a paint layer, that purple stuff, but you can see some of this paint layer has kind of chipped off, as paint does. And so you have this kind of two sides of this metal. You can see there's a nice little water bubble, and in which there's probably at least a little bit of acid. And so you can see what goes on during the cathode and the anode. In the cathode side, oxygen is combining with H+ to form water. And on the anode side, iron is going from Fe0 to Fe2+, and then combining with oxygen to form rust. And so rust does not have the same properties. Iron oxide does not have the same properties as iron, and so it's very bad. So obviously the question is how to prevent this from occurring. There's a bunch of different stuff you can do. You can give it a protective coating. So that could be something like a paint, but as you can see, that can chip off. Another thing is to galvanize it. So you see maybe like galvanized nails or something like that. So we'll call that galvanization. So galvanization is basically when you cover a metal with a metal that's already been oxidized. So it can't be oxidized anymore. But the thing about some metal oxides is some metal oxides are still strong. So something like iron oxide is still strong, is weak, but some other metal oxides are still strong. So basically you just coat it with a metal that's already been oxidized, so nothing can really happen to it. And then finally, the kind of another idea you can do is you can use a sacrificial anode, right? Anode is oxidation, so you can give your system something else to oxidize other than what you're interested in preserving. So on this picture right here on the right side, you've got the thing to be protected, right? You want to protect this thing. And so what you do is you attach it to something else that's easier to oxidize, something like magnesium. And so the magnesium will be oxidized instead of what you want to protect. And so the only thing with sacrificial anode is that it has to be replaced every now and then because it gets used up. The most common place this is used is in a hot water heater. So if you have a hot water heater every couple of years or so, you need to replace the sacrificial anode because it gets used up.